Why is radiation important in low-temperature heat transfer applications? Imagine trying to warm up a cold room with no heaters or radiators, just the cold air and maybe some insulation. How does heat actually move in such chilly environments? That's where radiation comes into play. Unlike conduction, which needs direct contact, or convection, which relies on moving fluids, radiation can transfer heat across empty space or air gaps. This makes it especially vital when temperatures are very low. At low temperatures, conduction and convection slow down because the thermal gradients are smaller and fluids move less. But radiation depends on the fourth power of absolute temperature and the surface properties of materials. This means even at cryogenic temperatures, radiation can still transfer a significant amount of heat. For example, in space or in cryogenic systems, gases are sparse or absent, so conduction and convection are limited. Here, radiation becomes the main way heat moves. Materials and surfaces matter a lot in these situations. Surfaces with high emissivity radiate heat more effectively, while those with low emissivity reflected more heat and lose less. Engineers can design surfaces with specific emissivity levels to control heat loss or gain. For instance, space shuttles use reflective coatings to reduce heat transfer through radiation, helping keep the spacecraft at safe temperatures. In cryogenic systems, like those used in superconducting magnets or low-temperature sensors, managing heat through radiation is key. Proper surface treatments can help keep these devices cold or prevent unwanted heat from entering. Spacecraft also relying heavily on radiative heat transfer. They use reflective coatings to control how much heat they gain from the sun or lose to space, maintaining stable temperatures. Another interesting aspect is near-field radiative heat transfer, where surfaces are placed extremely close, within a micron or less. This proximity boosts heat transfer beyond traditional limits, which is useful for micro and nanoscale devices. These tiny systems need precise thermal management, and radiation can be tailored to meet those needs. In summary, radiation plays a crucial role in low-temperature heat transfer because it offers a way for energy to move without needing a medium. By understanding how materials emit and reflected thermal radiation, engineers can design better insulation, cooling systems, and space equipment. This makes radiation indispensable in many low-temperature applications across mechanical engineering.